Welcome back to the deep dive. Today we're cutting through the noise to look at a small piece of hardware with a massive job.
A really massive job.
It's the NTI E-AVDS-4G3-P 4G automatic voice dialer. Now, our sources detail how this provides critical automated alerts in places, like a remote water pumping station, where traditional infrastructure just isn't an option.
Exactly. No phone lines, no internet.
So our mission is to figure out how this little box keeps things running when it's miles from anywhere.
Yeah.
Okay, let's unpack this. What is the primary operational problem this device really solves for someone?
Well, it's the reliability problem. It completely cuts the dependency on, old copper phone lines. The core utility is that it's just ideal for remote places without conventional phone lines.
Right.
Think about that pump station you mentioned. If a pressure sensor fails, you need to know now, not next week when a maintenance crew happens to drive by. This device is that crucial cellular bridge from a sensor failure to a person's cell phone.
And the trigger itself is specific, right? It's not just a constant check-in. It only activates when a sensor goes outside some kind of preset threshold.
That's it. That configurability is key. The device is basically dormant until, say, a temperature spike in a server closet or a critical valve opens.
And then it springs into action.
Immediately. And it's robust. It can call or send an SMS to up to 8 different telephone or cell phone numbers.
Hold on, 8 people. That brings up the idea of, alert fatigue. How does it know when the alert has been handled?
Ah, that's a key operational detail. It's not just a blind broadcast. To stop everyone from rushing out there, the device requires an acknowledgement from one of the recipients.
Like pressing a key on their phone.
Exactly. A simple key press stops the dial cycle. If the first person on the list doesn't answer or acknowledge, it just moves right on to the next one until someone takes ownership.
Okay, we should touch on the messaging limitations,
Yeah.
because they seem pretty strict. You get one outgoing voice message, 20 seconds max.
Right.
And the SMS message is capped at 70 bytes. I mean, 70 bytes in this day and age. What can you even fit in there?
It forces a kind of creative discipline. You're not sending a paragraph, you're sending a code.
Like an error code?
Precisely. PMP1 faulty temp, and a number that corresponds to a fault sheet. It's for triage, not detailed diagnostics. And you do have to bring your own mini SIM card, of course.
All right.
NTI just provides the hardware.
Got it.
Now, here's where it gets really interesting, especially for global use. The network support. This is what makes it so versatile.
Okay, let's talk connectivity. You mentioned the bands. I see 4G, LTE, FDD, and TDD bands listed. Why is that complexity so important for the user?
Because it means longevity and location independence. In simple terms, FDD is what most major global carriers use. TDD is often for denser specific networks.
So it covers all the bases?
Covers all the bases.
Yeah.
It means this device can work on a 10-year-old site that's still on 2G GSM, which it also supports, or you can move it to a brand new facility using the latest 4G. It maximizes uptime basically anywhere in the world.
That resilience is definitely the selling point.
Yeah.
So if it's managing all these networks, it must be pretty tough physically and efficient. It's small, but what about power? It draws a max of 350 milliA at 12 volts. Is that low enough to run off something like a small solar panel or a battery backup if the grid goes down?
Absolutely. That low power draw is designed for exactly that kind of setup. And it operates from 39 to 140 degrees Fahrenheit. It's built to survive in a hot shed or a cold cabinet.
And what about wiring it up to the actual sensors? It mentions interfacing with the E-MAN LXO, but what about sensor flexibility?
The versatility is huge there. It uses standard output relay connections, and it works with normally closed or normally open circuits.
So it doesn't matter how the sensor is wired.
It doesn't. Whether a circuit breaks or a circuit connects when there's a fault, this device can handle it. You're not locked into proprietary sensors, which is crucial in the field.
So just to quickly run through the package details for you. The price today is $250. It comes with a 2-year NTI warranty, and they even offer a free 15-day trial.
So what does this all mean? I think the value proposition is pretty clear. This thing is the definition of distributed reliability. By supporting basically every major cellular standard from 2G to 4G, NTI gives you a solid, low-cost way to prevent failures where a landline is either impossible or just way too expensive.
That makes perfect sense. So here's a final thought for you to mull over. Considering the incredible breadth of bands this supports, from legacy 2G to modern 4G, what unexpected remote applications, maybe something like historical preservation and really accessible sites, or even deep-sea buoy data, could this kind of broad connectivity enable in the future? Something to think about until our next deep dive.